Alright, so hello everyone. My name is Tathagat Kumar and I will be giving you a presentation on Docker, both for web and app deployment. So before we get into it, let us talk about what Docker really is. So Docker is basically an open platform for developing, shipping and running applications. But how is it? I mean, that doesn't explain what Docker really is, right? So to understand it, let us look at what initial steps that any web developer or app developer takes. Like you have started a web project, let us say. What is the first thing that you do? We download dependencies, maybe run npm install to get the initial modules, and maybe then add more that we need. Or for a Flutter developer, you might be just doing Flutter pub add whatever dependency you want, like Rive or HTTP, the initial steps, and then you write the code and then you deploy it or run it, whatever you want to do. So that is the initials, or rather the whole plan when you're making a whole functioning application. Now, what Docker does is that it streamlines that whole process, makes it easier, more efficient, and practically it makes your job a lot more easier than how you would do it manually. But let us talk about it more in the next slides with the topic of containers, as that would explain it a lot more better, right? So now, why use Dockers? And that is the question that is can be actually answered by containers itself. Normally, one might think that, okay, we have this problem, it makes it efficient, but cannot anyone just make it manually more efficient? The answer is not really, unless you can make your own containers. But a container, let us say right here, is very lightweight, isolated, and if you want to know how does it work, let us say you have a box inside a laptop, alright, or PC, whatever you're using. You pack it up with all the dependencies that you want, with the app source code and whatever you have it. And then whenever you want to deploy it, this container as a whole functions along with your application. Let us say you didn't have the container, then it would rely on your PC to start. While with the container, yeah, the container is all that it needs, along with, of course, and host OS, which I will explain about it later. And that actually makes containers a lot more efficient to use when you are making an application. Now that that's explained, let's talk about what it was like when there were no Dockers. So you can imagine, like, we are in the most advanced generation right now, but in the early days, it wasn't really good scene. Like, for example, developers relied highly on like the ID developers whenever they wanted to, download a dependency and then deploy it on the server. Because let us say, I think this is the problem that we might have globally faced. Like, you have made an application, you install your dependencies. Let us say that dependency was at version 1, right? Now, later on, you realize that the dependency version has changed to 1.1 or maybe 1.2, whatever it is. Maybe, I mean, it, of course, every dependency keeps changing the version and updating. So, earlier, when that happened, the developers basically had to rely on the IT developers to tell them, okay, okay, I want this dependency to updated. Alright, so they had to work with the IT developers to basically install that one single dependency at a time, and that would make their job way too tedious. And considering that dependencies kept changing repeatedly, it was a lot more hard job, and that explains your complex dependency management. Now, furthermore, not just that, the problem is, let us say you made your whole project by installing the dependencies, running the code. Now, let us say you are running it on the client PC. You might realize that it is not running there. So what's the gas there? The thing is, when you're running it locally, you have dependencies in your OS, but that doesn't explain for the OS of the host or any other PC that you might rely on. So that is one problem that existed earlier. Again, slow deployment because the intermediate between the developer and the server were earlier the IT developers, and the resource efficiency, of course, because you have to download a lot of dependencies, which took lots of resources to do. Now, moving on, let's understand containers a bit more. Not just the layman language that I talked about with the box, but rather than what it does. So, containers are basically, mm, let me explain it this way. So, container, I told you that it's basically a full-fledged application, right? Like it can run your application on its own without relying on anyone except the host OS. That basically packages your whole application with utmost entirety. Not even your PC can do that. You will need a container to do that. Along with that, you can of course export it where you want, and that makes it portable. And of course, whatever you keep in the your container is dependent, so that doesn't do anything at all. Much more like a virtual environment that you might have used in any project that you might have worked on, along with of course efficiency, because it cuts down a lot on resources. Now, you might think that okay, so packs it packs a whole application inside itself. It is portable. Along with that, it works efficiently. So, doesn't sound similar to VM? The answer is yes, but they are both different. And to explain that, let's see this a comparison chart. So, as you can see here, while they both might be similar, a container is rather more faster and a smaller unit when you want to deploy an application. Like as you can see, the boot time as well as the performance of container is both faster than VMs. And the resource usage, as you can see, containers use a minimal of megabytes while VMs use gigabytes. And honestly, to explain that, which I will in the next slide as well, containers basically depend on the host OS. They do not have a host, they do not have a OS of their own. While VM work independently on their own OS. Alright. Along with that, the containers are highly portable, while VM are less portable. And I don't think I need to explain that, as containers are lightweight while VM are rather bulky. Now, as you can see here and ponder, in a VM, they have their own app and guest OS connected with the client side with the host operating system. Here, the guest OS and host OS both work in a synergy, in a cooperation, of course, and that explains why VM is rather slower and bulky. Because, of course, uh, the guest OS, that to multiple, takes a lot of resources as compared to your containers. Where, as you can see, the Docker engine has no OS except the host OS to rely on. So Docker engine single-handedly just uses the application, uses them and binds them with the host OS as an intermediate, and that cuts down a lot on resources as well as the functionalities, making it a viable tool when you are using it solely for an application. Now, for the key Docker concepts, I will come back to it later when I will be demonstrating it. But furthermore, let me just explain what a Docker image is. It is basically a blueprint to as a data file to how will I make a container, right? Now, let us just take it as a simple line that it is basically a simple file where we tell it, okay, so the container that we are going to make will have this dependency and this code and etc. etc. Right? So moving on furthermore, let's talk about Docker registry. Now, as we talked about Docker images before, Docker registry is rather a system for storing and managing Docker images. There can be more than one Docker registries, which there are, but globally, the only Docker registry that most people use is Docker Hub, which is also the biggest Docker registry there is. Now, the user registry, you can use it to pull practically any Docker image that you need. Alright, so let me here demonstrate with an example by going into the web, the official page for Docker Hub. From here, you can basically download any image that you want, for example, PyTorch or TensorFlow or BusyBox, Alpine, MongoDB, MySQL, Postgres. But for my example, let us just go with Nginx. And here, as you can see, you will get everything from the tags, versions, even how to use this image. But I will show you it in my own way by just simply going into my terminal. Right. So now, firstly, let us check upon how to look at our images, number of images that we have. We have made none, so we have none. Same for the containers. Enter. Similarly, see it right here. Now that that's done, also make sure that you have your Docker desktop engine running in background or Docker if you are in Linux accordingly. So now that's done. Let us pull an image with a version tag bookworm. For that we will try docker pull the name which is in the x colon bookworm which is the tag and press enter. We will see that slowly it is downloading. And that's done. Docker images enter. It's done. And that is how you download a specific bookworm tag. Now, if you want, you can actually just do like a docker pull nginx, and by default it will just download the latest tag that the person has. And as you can see here, we have both of them now. Now, as I told you before, the docker images are basically the instructions of how to make a docker file, or rather a container. So now how do we do that? We just simply do docker run the image id, copy, and there we have it running. And to check, we just need to make a new window from there and just see that it's running right. Now the problem is that here is actually blocking the terminal. So to make things easy, we can just make it run in background by just typing up docker run -d, where d stands for detach, and of course the image ID, and not just the image ID actually. We will need to bind it to a port. Now, why do we need to bind it to a port? Actually, by default in Docker, we see that whatever ports that are assigned to any container are in an isolated system and cannot be accessed if you haven't binded the port to your system properly. So for that, we basically expose the port of the isolated Docker system and then bind it to a system port. Now, as to how to do that, we use an extra parameter which is -p for port binding, then port name. Initially, I will do here 8080 and one more 80, and here, or rather, let me just do 8080, because by usual convention we just do keep both same, press enter, and there we have it running. Now when you look at it, as you can see, it's running in port 80 from the isolated Docker system. Now let us just quickly access it. I'll show you how to do it from desktop actually. It will automatically open for it for us in the browser itself. Now here, as it's running, you can just open with browser, and you'll see that is how what we needed. Now that we know how to make a container by scratch, let us just go upon and ponder upon like what is a registry and a repository. Alright, so as we talked before, a Docker registry is a collection of images, right? As we saw before in my explanation as well. But the catch is that it's also a collection of repositories. And how is that? Because a repository is also a collection of Docker images, but that are stored in a registry. So here's the difference. Even though registry and repository both are a collection of Docker images, the registry is the one encircling them all. So it's like a registry is a collection of repositories, but a repository is not a collection of registries. So that is how it is. Now that we have talked about repository as well, so let us take our time and look what private repositories and public repositories are. So for public repositories, as you can see below, that an official service, for example, NGX that we saw before, just Redis or maybe even Postgres, comes under public repository. Why? Because it can be accessed by anyone in the web. So it comes under the public repository. Of course, as the name implies, or other definition, a private repository is something that is accessible by one individual or maybe let us say an organization. For example, my app may be a custom made image that you made for yourself, published it on the Docker Hub for your own usage. So that comes under the private repository. Now, these are the steps for Docker introduction. In case you wish to use Docker and then implement it for your production servers, which most of the people do these days. So for that, let me just give you a final implementation by making a custom image on Flutter Web. So here, as you can see, I've made a demo program for you all to explain how to make a Docker file for the Flutter Web. So from here, let's first see that it's basically a simple program with only one dot file, where I've just made a simple algorithm to where just a shape changes with a tap of a button. That is not important because we just need the demonstration for the Docker file. So let me just try to explain what I've done right here. So basically, I have first chosen the environment, or rather the OS, on which our Docker file will try to build. Here I've chosen Debian latest version so that it can build with ease. Plus, for Flutter, Debian is, I think, the desired OS. Now, now that is done, we run a few commands to update our environment with apt-get update and install all the necessary updates that we would need according to the versions. And then we define the Flutter SDK as well as the Flutter version, because those are the dependencies that we would need later on, and I will show you. As you can see, the Flutter version that I am using right now is 3.24.5. The SDK is been taken from my desktop itself. I mean the PC, and then we clone the Flutter from a GitHub link, as well as same for the Flutter version. Then we basically set an environmental variable path itself from for our container. Now then, after we are done setting up all the Flutter dependencies, we do an additional check with Flutter Doctor, even though that's not really necessary, but we are doing this in case if we get any unknown error. After that, we just basically set up the file making by first making the directory, copying all our files, which is basically main.dat here, and then setting the working directory to the app. After that, once we are done with almost everything, we run the Flutter clean pubget, and then we build the web. Now after that, for using the ngx to deploy, we use the ngx dependency 1.25.2 Alpine, even though you can use latest as well, it doesn't really matter. And then from that, we copy it into we copy it directly into the ngx, the main files, and then we expose 80, or rather 8080, no 80 is fine, and then we run it using the cmd command. The cmd command is important because we are making an ngx server. So now that I've explained the code, let me just show it practically by building one. So what do we do is docker build -t. Let's say my app, this is the name, and let us give it the tag latest, and the present directory that it is in is right here, because Dockerfile is basically in the main directory. So we press enter, and that's how it goes. Now as you can see, it's slowly building our whole image. It will take a while at first, but it should be done smoothly. Also, while it's generating, I wanted to clarify that right here. Once we have like built the Flutter web, why are we calling Nginx? That might be a question that might pop in your head. So that is because we need something to deploy our web server, right? Web actually, right? So Nginx is the dependency that will help us with that, and that is why we have got that. Other than that, I don't think so there should be any problem. If there are, you can just ask me any questions in the end. Let it just fix real quick. Alright, so as you can see, everything has been done, and when I hit Docker images, now we have three images, with one being my app latest. Now that we have made our image, how to run it, we will do it the same exact way we have done earlier. With docker run -d sp. Now I will expose it to 8080, and 80 was its initial. Also, to give a name to your container, you can use the name parameter with double hash, and then let us say my app. After that, we specify what we are using as an image, which would be, let me just get the image ID that is right here. Copy, paste, and it should be done. Now as you can see, it's running. Let me just open it up in a new window. Wait a minute. Localhost 8080. Now as you can see, it should be running. Yes, you can see the demo program is running, and when you click it, it is doing exactly as our code defined. And that is how you basically make your Docker file, and that should be it. If you have any questions, please let me know, and thank you.